Now we want to consider what happens when the two exponents that we have are negative numbers. So we've explored the evens and the odd relationship. So I just assume that we're going to see kind of a similar relationship with the even exponents of the equation, and similarly a different pattern is going to exist for the odd exponents in the equation. So we're just going to start with the even and just kind of see what happens. Again, we see that the 0 still holds that nothing is going to happen when we have the 0 exponent. But just moving it to -2, we get this new kind of cross-like shape that we have going on here. And the further we move our exponent away from 0, we see that it is just slowly approaching those points still that we saw in the previous video of 1, -1, -1, -1, 1, -1, and 1, 1. And again, we've explained why those points can't touch, and if you have any more questions, just go back and watch the video about even and odd and their relationships and that for that answer. But for now, we just want to kind of see if there's any patterns that we have going on here with the negatives. So the patterns do still apply where the even exponents, even though they're negative integers now, they still kind of follow a similar thing where they approach those points but never actually get there. So let's see if the same thing happens for our odd exponents. So now just looking here, we see that our odd exponents kind of have these curves going on that seem to try to approach each other, but there's still space and they don't touch each other. So let's see what happens when we get further and further from 0. So it appears that they tend to sharpen, I guess is the best word that I can use, and still never touch these points, even the closer that we get to a larger negative exponent. So the further away from 0 that we get, we see that they still just never touch those points. Going back to my even exponents for the negatives, I immediately just noticed that there is this similar thing going on with all of the parts of the graph, that they just seem to approach these points, and I wondered if there would be maybe a circle or a square for these smaller numbers that would connect all 4 of these points. So we're just going to start with a equals -2 for our exponent. And this really was just done through trial and error. So we have this equation, and we have positive exponents for this because we saw that in the even and odd video that they will create those shapes that we're looking for. So my first idea was to just take the negative exponent that we're given and multiply by -1. So essentially we're making this negative exponent positive now. So I'm going to move this up to the exponent of 2. So these are going to be both squared. And now for g, I just assumed that it would be 1 just to see what would happen, and we immediately see that 1 is not big enough to reach all of the points that we're trying to reach. So there's still a lot of space that we need to cover. So then just trying to grow the circle, we see that this is too big, just trial and error. We finally see that 4 actually, when this equation equals 4, that these lines actually intersect and touch. Now, my first thought was that we're just taking the integer that we have for the exponent and squaring it. So essentially we would know that this works because 2 squared is 4 and -2 squared is 4. So I wanted to see if this still held for another number. So we tried -4, and we see right off the bat, well, first we have to change this. We see that right off the bat our theory was wrong because 4 actually works here. When g equals 4, it works that they all touch, instead of when g would equal 16 as I originally predicted would happen. So then that begs the question, how does this work? Why does this work? So I figured there should be a relationship between this G value and this 1 that we have here. So I decided to try changing this 1 value to see if they would still correlate that the 1 and the G are actually related. So I decided to change it to 4 just to try to keep like the perfect squares idea going. Of course, any number could go here, but for the trial and error. So from here, I just tried to find a number in which all these points would connect. So again, my exponents are still -4. So what I did is change this G. So I see that immediately this is too big, so I have to go smaller and smaller. And again, we're back at this 1 and this 4 being related. So then I just kept wanting to try different numbers. So I put in a 9, and I could even change my exponent here if I wanted to. So I could say -12, then I'd have to change this to 12. So then I wanted to look and see if there was any points that I could have at G such that it equals. So I see that it actually has to be between 1 and 0. So I'm going to change this really fast, between 1 and 0. And I'm just going to change it to 0.1 just to see if we can get there. So here we have our graph just shrinking and shrinking, and it almost touches, but then it just so it's got to be between 0.4 and 0.5. So again, we go back and change this to 0.4 and 0.5 by steps of 0.01 just to see when that point occurs. So we try to see as close as we can, and we can even zoom in here just to make sure that they actually are touching. So it seems that at 0.44 they are so close to touching. They are just so close. So then we want to look even further and just see what happens. And I just started messing around with some numbers, and I actually posed this problem to my classmate Tyler Hamilton again, and he suggested putting in the fraction 4 divided by 9, which is just 0.4 repeating. So we see that it actually does touch here. Now, the question then arises, how are 9 and 4 9s related? So we see that there's obviously a 9 in the denominator, and the 9 here equal. So just continuing to try this, we see that this pattern happens over and over again, that whenever we put in a different number here, we have to adjust this number here in order to get that end result of having all of them touch. So after sitting in the library for at least an hour and just looking at this problem, Tyler and I made this chart that showed, what we would have this equal and what this number would equal, and just trying to find a relationship just in any way that we can, until finally Tyler suggested that we take the reciprocal of this number. So we basically raise 9 to the -1, so that we'd have like 1/9, and then multiply that reciprocal by 4. So we're not really sure where the 4 came from whenever we worked with the exponent being -2 and 2. We assumed that just came from the fact that the radius that we took here, and then we squared it to be, 4. But my hypothesis was that you needed those 4 points in order for it to connect. So multiplying that 4 by the reciprocal, we see that we get this number that we need in order for those points to connect. And if you go through and play with this, you actually see that this works for almost every number. So For instance, when we have this equal to 16, so we know that the reciprocal of 16 is 1 over 16, and then we multiply 1 over 16 times 4, and we get 4 over 16, which is actually just 1/4. So we have 0.25, which shows you that these all cross here. Now, we were not able to come up with more reasoning as to why this happens, but we thought this was a really interesting aspect to the negative numbers and wanted to just share it out. So then I just started thinking about whether or not this could apply to our odd exponents as well. So if you just recall, our odd exponents create this graph in which you have two curves that seem to be approaching each other but don't ever meet. And they also seem to be approaching this 1, 1 as well. So just seeing the different graphs that are made, the smaller that the exponents get, we see that they also kind of sharpen and try all their might to get to these points, but just never fully reach them. So thinking back to what we just discovered with the even exponents, we want to try and apply these same things to the odd exponents and see if they work too. So we take the similar equation and we also take just, this exponent and we multiply it by -1. So -1 times -1 is 1. So we have C is 1 and we get this straight line. And now we're trying to see if there is such a shape that would connect at all to either of these points. Now, the hope and expectation is that we're going to find something that connects both of them, but we're just going to see what happens and how this works. So we're increasing this h value, which is what we've set this equation equal to. So as we get bigger, we see that it actually is only going to cross this upper curve that we've created. And again, the 4 and the 1 are related. So we showed previously why that works because of multiplying the reciprocal of 1, which is 1 over 1, and multiplying that by 4. So that's how we get this 4 value. And so seeing this, we want to continue to check and just see if it works for other numbers too. So we just go up here and change this so we can think of doing this and set it equal to 4. And we know for the other exponents that it would work when we would make this equal to 1. So just knowing that information, we slide it back down to 1 and see that we have. And again, Tyler and I were not able to come to a conclusion as to why this occurs with the negative numbers. We just thought that this was a very interesting pattern that they follow for both the even and the odd, as well as how the reciprocal multiplied by 4 just kind of creates this connection, whether it be at one point or whether it be those 4 points that we saw with the even numbers.